Hey everyone, today we are diving deep into Apache Spark in Azure Synapse Analytics. By end of this video, you will understand how to analyze data, transform it, and work with Delta Lakes, all using Spark Pools in Azure Synapse. We'll cover three main topics, which is analyzing the data with Apache Spark, transforming the data using Spark, and also using Delta Lake for advanced data management. So let's get started. First, we are going to cover about the Apache Spark and how we are going to use that in Synapse Analytics. So before deep diving into the topic, let's understand what is meant by Apache Spark. Apache Spark is a distributed data processing framework that allows you to process massive amount of data in the parallel across multiple machines. So the key features here are you can write in multiple languages like Python, Scala, and also Rust, and you can process data in parallel across worker nodes and works with distributed file system. And the Spark uses a driver executor model, which means the driver program coordinates everything using Spark context, and the executor runs on the worker nodes and process the data in parallel. The data is distributed across these executors for faster processing. So you can see the diagram which mentions that the driver node pushes to the cluster node, and the cluster node pushes the data to different executors where the Apache Spark pool has, and these executors take care of all the data in parallel sequence. So that is what Apache Spark means. When it comes for the Azure Synapse, it uses serverless cluster that auto starts when you need them, and it auto stops when idle to save the cost, and it can also auto scale based on the workload. So it is tied to a specific Spark runtime versions. So the main benefit of using Spark pools inside the Synapse Analytics is that they don't need any infrastructure management, so that we can just focus on the code. So in the next section, which is nothing but how to use the Spark in Azure Synapse Analytics. So it gives us the integrated notebooks with which we'll be able to syntax highlight, and also it gives us the error support, and it helps us to automate the code completion. It has interactive visualization and also export capabilities. The Spark in Synapse can read from primary workspace, data lake, and also linked storages. It can read from Spark pools, Azure SQL servers, Cosmos DB data explorers, and also from Hive meta stores. From these multiple stores, it can read the data, and we can transform or perform ETL operations inside the data. In the next section, we'll be deep diving into how we can use the PySpark inside the data frames. So if you see in this particular code, which says df is equal to spark.read.load. So in the first line, we use this PySpark, which is nothing but a command which tells the notebook how to use the PySpark. And then we have this spark.read.load, which is a method to read the data, and then we have the location which says the path for our CSV file, and then we mention the format, which here is nothing but the CSV file. Similarly, whatever file format you have, you can mention that particular format here. And then we mention the header is equal to true, which tells the Spark the first row contains column name, and we store all these data inside a data frame variable. And then next statement, we manipulate the data. So in order to manipulate the data, we use the select clause to select two columns from our data frame, and then we use the group by clause, which helps us to group all the rows by the category column. So we have these two columns, which is the product ID and the category, and we group by them with the help of category column, and then with the help of count function, we count how many products are in each category, and then we store all the results in a new data frame variable called counts underscore df. And then finally we display the result with the help of display function, inside which we give the counts underscore df as a parameter. And as a result, you can see the below table, which gives us the output with the category and count of each category under each particular column. So you can see this output. So in the next section, we'll be seeing how to use SQL within Spark. So in the earlier example, we saw how to use PySpark. Here, we are going to see how to use SQL inside PySpark. So if you see the expression which is written here, the first line starts with the PySpark as it already has, and the second line we use this df.create or replace temp view. So in order to use the SQL inside the PySpark, first we need to create a temporary table. So we create a temporary table called products from our data frame. So this table exists in the Spark metastore and can be queried with SQL. And if you see in the next line, we have this spark.sql, which is a method to execute SQL inside Spark. And if you see in the end of this line, we use this slash, so it helps us to allow to continue the query on the next line. And we use the select class in order to select statements, and with the help of from class we'll be able to query from our temporary view. So if you see, we have mentioned the products table which we created earlier with the help of create or replace temp view function. And in the where class we mentioned the category like filters for specific categories. So after that, we use the display function to display the particular data frame in which the results are stored. So this is a way to use SQL inside PySpark. Let's say if you want to use pure SQL in a notebook cell, it is also possible with the help of this particular command, which is percentage SQL, which helps us to use the whole SQL, pure SQL, instead of using SQL inside PySpark or using PySpark. So here you can see it has a default select class, and it counts the product ID as product count, and we use the we select all these from products table, and we group by with the help of category, and then we order by them in ascending order of category. So that this is how we use the SQL inside notebook. So in the next slide, we'll be seeing about visualization data. So the Spark notebooks supports built-in charts, or you can also use library like Matplotlib. So if you see the first diagram, which is nothing but the built-in notebook charts, but if you see the second diagram, which is nothing but a graphics package. So in this, we use Matplotlib. So we imported PyPlot inside the Matplot library and named it as PLT, and we have a figure of 12 inches wide and 8 inches width, and we use a bar chart here. That's why we mentioned plt.bar. So let's say if you want any pie chart or any other chart, you can mention it accordingly. And here we have the x is equal to data, and inside the data parameter we gave as category, which means category names on the x-axis, and in the height we mention it as products count, which means the product counts as a bar's height. And for the color we have mentioned as orange, which means the bar chart's color will be of orange, which you can see this the diagram. And then with the help of plt.show we'll be able to display the chart. So that is all the first section is about. So this is a small knowledge check. These are the questions. You can pause the videos and try to answer these questions. So here is the answer for each and every question. So let's move to the next topic, which is transforming the data with Apache Spark in Azure Synapse Analytics. So until now we saw how to use PySpark and also SQL and also use visualization data inside notebook. Now we are going to see how to modify the data and also save the data. So if you see the first code which is written here, we have imported certain functions like year and call. So in PySpark, we don't have default functions to extract year from the date and also to select particular column in a table, unlike SQL. So for that, import certain functions like PySpark.sql functions, and then we import this year and call functions in order to extract year and also reference a column in a data frame. So if you see the first line of code, That's what we have done here. And to load the data, as we know, we use spark.read.load and then mention the file location with the format and also header mention. And here we add the year column and derive the order date. So we use the data frame with the help of with column. We mention the year, and then what we do is we are going to name the year with a new name, which is the year. So for that, we need to select the year, right? So in order to select the year, we are going to use the year function, and the year function, we need to give a parameter of the year, right? So in order to select the parameter, we are using the call function in order to reference a order date column. So that's why we are using call and mentioning the order date column, so that from the order date we can extract the year and name the new column as year, and all add all the years in the year column. And then you can save the transformed data with the help of this particular code, where the df.write helps us to have the write operation, and with the help of dot mode overwrite you will able to overwrite it if the file already exists. And then we use dot parquet, which helps us to save the in the parquet format. And then we also mention the location so that the destination path is filed out. And then there is a new topic called partitioning data, which helps us to split your data into folders for better performance. So if you see that in the next slide, we have this particular line of code which says dot partition by of year, which means we are creating separate folders for each year. So this creates a structure like data slash year 2020, data slash year 2021, etc. So why do we do this? When you filter by year, Spark only reads relevant folders, not all the data. By this, you'll be able to increase the performance. So that's the main use of partitioning data files. So the next topic is about transform the data with SQL. So until now we saw how to do the transformation in PySpark. Now we are going to do the same with the help of SQL. So whenever we are dealing with SQL inside the notebook, we need to create a temporary view. So that's what we have done in the first line of code. And in the second line of code, we are selecting certain columns and then we are modifying the data. So unlike PySpark, where we need to import the year and the column function, SQL defaultly has all those functions. So if you see here, we can import the year with the help of year function, and then we can name it as year, right? And we can also select any particular column with the help of select clause. So that's the advantages of using SQL. So and then we save the particular file with as an external table. So saving as an external table as an advantage, where dropping an external table does not delete the data files, whereas dropping a managed table deletes the files also. So you'll be seeing that in deep in the next upcoming slides. So this is all about the transforming data with SQL. So there is a small knowledge check where you can pass the screen and try to answer them. These are the answers for that. Next topic comes from the Delta Lake. So there's a concept called Delta Lake inside the Azure Synapse Analytics. Let's see what it is. So before deep diving into it, let's understand what is Delta Lake. Delta Lake is an open source storage layer that adds database features to Spark. The key features are it supports ACID transaction, which helps for reliable data operation, and it also has the data versioning where you can track changes over time, and also helps for time travel where you can query previous versions, and have schema enforcement, which helps us to validate data structures, and it works with batch and streaming datas, and also uses standard Parquet format. So the how we do use this data lake. So here is the code for that. You can create a delta lake table with the help of data frame. So for that, first we need to load the data, which we do with the help of spark read.load function, and then similarly in the parameters we need to mention the folder location, format, and also the header, whether it's true or false. And then we create a data frame, and then we mention the location, define where we save them. And next comes the important factor. While saving the data, we mention the dot format as delta. So this is the key. It saves as a delta format instead of Parquet format. And then we use a dot save and save the delta table path. So inside that we dot save, we mention the destination path. So this is powerful. Why? Because instead of doing, you know, while making the conditional updates, we update only specific rows. If you see in the second snippet of code, we, with the help of delta table, we only modify the particular function, the particular row, which is the category. Inside the category, we only modify the price by multiplying it into 0.9. So with the help of this conditional updates, which makes the delta lake tables unique from the traditional data stores. And also we'll be able to use the previous version, which is time travel. That's one of the key features in the delta lake. If you see dot options of version as of comma 0, which mentions this is the first version. So let's say if you want to roll back to any other versions, we can mention that particular version number here, and then we load the data from the delta table path. This is how we create delta tables with the help of these particular functions. Next comes with the catalog tables. Inside the catalog tables, we have two tables, which is external and managed. So managed tables, so let's say we are dropping the table, it deletes all the files. In the external table, while dropping the table, it doesn't delete the files, only deletes the, only drops the table. So in the managed tables, defined without any specific location, but when it comes for external, we define the specific location. So if you see in this particular code in an external table, so the main difference here is while saving the table, we mention it as external. When it comes for manage, we mention it as manage. We'll be able to create a table with the help of using delta, so which helps us to specify the delta format, and then with the help of location we make it external by pointing to the existing files. So this is how we define the catalog tables. So if we move to the next slide, we'll be seeing about how to use the delta lake with streaming data. So if you see the first piece of code, which tells us how to use the dot read stream, where we start to read the streaming data. So earlier we used dot load, which is used to used for batch datas, but when it comes for streaming datas, we use spark dot read dot stream, and then with the help of dot format we mention what type of format we are looking at. And then in the options we have certain parameters where it tells about ignore changes and also comma true, which means we ignore any updates or deletion during the process. And the true mentions that if any data happens, it mentions that only if any new data appears, then process those datas. And with the help of dot load we specify the delta table path, and with the help of show we show the streaming datas. And if you see the streaming sync, which is mentioned here, the first line as usual we read the streaming datas, and inside the table path we mention what type of table, the destination path we are looking for, and then checkpoint path, which tracks the processes of the datas. And then with the help of dot write stream, we'll be able to write streaming datas into deltas. And then we enable dot options, which helps us to able to recover any deletion happens. And then with the help of start, we begin the streaming. This is all about streaming the datas using the delta lake. So if we move to the next slide, which tells about using the open rosette function with the help of SQL. So if you see, open rosette is the SQL function to query the external table. So inside the open rosette function, we have this bulk, which is the URL of our Delta Lake table. And after that, we have the format, which mentions what type of format we are using. Now we can use the SQL to query Delta tables without Spark. And also we can use the Spark metastore tables, where this particular code tells us how to use it. With the help of select class, we'll be able to select what type of table we are using. This query table created in the Spark metastore directly with the help of SQL. So this is all about the data. So coming for the conclusion, the recap, what we have learned is, we learned about Apache Spark basics, distributed processing frameworks, serverless Spark pools in Synapse, and also about autoscaling and autostop for cost efficiency. And also we learned about data analysis with the help of data frames, built-in visualizations, and we also saw how to transform the data by with the help of partitioning data for performance, saving it as external tables. And also we saw about the Delta Lake, how to perform ACID transactions and all those stuff. And the next step would be of performing lab. So I'll do that in the next session. So hope you guys enjoyed this video. Subscribe for more Azure content. Thank you.